Hello everyone and thanks for watching Edupedia World videos. So let's start with our topic of atomic structure. I am Manish Agrawal and in this session of atomic structure we'll discuss the terms atomic number and mass number. Okay. So what is atomic number? Well, first it is represented by letter capital Z. Okay, atomic number is represented by letter capital Z and it is number of protons present in an atom, or you can say number of protons present in any nucleus of an atom, since all the protons are present inside the nucleus, okay, and not around it. We can also say it is number of protons in the nucleus or number of protons in the atom. Alright, for example, hydrogen atom has atomic number of 1. Alright, that is, it has in its nucleus only one proton. So Z for hydrogen atom, alright, Z for hydrogen atom is equal to 1. Okay, whereas if you see, say, a sodium atom, then Z for a sodium atom is equal to 11. That is, it has in all 11 protons inside its nucleus. That is Z value for sodium and this is Z value for hydrogen. Similarly for helium it will be 2. Alright, helium has only 2 protons and so on. Okay, and since you know that an atom is electrically neutral, number of protons in a neutral atom is always equals to number of electrons. So sometimes atomic number is also defined as number of electrons present in an atom. Okay, but that is true only for neutral atoms. Alright, so for example, if I have, say, a helium atom and if it is neutral, then I can say that number of electrons inside helium atom is also 2, just as the number of protons. Hence Z for helium atom is 2, which I can calculate either from number of electrons or protons. But if the same helium atom is charged, alright, let's say helium loses one of its electrons, so it is He positive now, or let's say it loses both its electrons, so it is He2 positive now. So does this change the atomic number of helium nucleus? No, it does not. Okay, the He positive still has a nucleus with 2 protons, so atomic number of He positive here is still 2. But now you cannot say that atomic number is same as number of electrons. Alright, similarly here helium has lost both its electrons, but this doesn't mean that atomic number has changed. The Z is still equal to 2. Alright, so only for neutral atom you can also define atomic number as number of electrons. The best definition is obviously the number of protons in any atom or nucleus. Alright, now let's move on to mass number. Now mass number is represented by capital A. So remember this notation, okay, this is standard notation, you cannot change it. So we know that atomic number is represented by Z, not A. It is represented by capital Z, whereas mass number is represented by capital A. Okay, so mass number is number of neutrons plus number of protons present inside an atom, or again inside a nucleus. Alright, for example, let's take sodium atom again. So a sodium atom has 11 protons with it, alright, and 12 neutrons with it. So total number of neutrons plus proton is 12 plus 11, that is 23. So value of A or mass number for sodium atom is 23. Alright, and similarly for hydrogen, number of protons is 1 and number of neutrons is 0. Alright, so its mass number is 0 plus 1, that is 1. So for hydrogen A is equal to 1. Alright, in fact hydrogen is the only element known to us which has no neutrons inside its nucleus. Okay, rest every element in our periodic table has one or more neutrons inside the nucleus. Alright, so hydrogen has only protons and no neutrons. Alright, again another thing is, are number of neutrons and protons same? As you can see from both these examples, it is not true. Okay, neutrons and protons might be same in number or they might be different. Okay, for example, carbon has 6 protons and 6 neutrons. So usually for lower number of elements, okay, for lower atomic number elements, This is true that number of neutrons often turn out to be same as number of protons, but this is not a rule and you don't have to remember it and you don't have to follow it. Okay, we'll just define mass number as number of neutrons plus number of protons, and since both these particles are present inside the nucleus, they are also often called as nucleons. Alright, and we can also define mass number as total number of nucleons. Alright, that is all the particles present inside the nucleus of the atom. You sum the number of all those particles and what you get is the mass number, capital A. Okay, so why do you call it mass number? We call it mass number because we know that this mass number doesn't account for electrons, and the mass of an atom is majorly because of presence of neutrons and protons. Okay, we ignored the mass of electrons. In fact, in a unified mass scale or atomic mass scale, we assign neutrons and protons a mass of 1 unit each, whereas we assign electron an approximate mass of 0 units. Alright, so that is why the total mass of an atom can be estimated by simply counting the number of neutrons and protons. Alright, and we can say that approximately atomic mass of any element is equal to its mass number. Okay, so remember this. In fact, if you want to go into the significance of both atomic number and mass number, we can see that first let's look at the notation how we write atomic number and mass number. Say x is any random element of our periodic table. Alright, x is any element of our periodic table. Then beside it, okay, we write the atomic number z and mass number a. Okay, so this is the standard notation for any element. You always write the atomic symbol. Alright, for example, say helium, it has atomic number of 2, alright, and mass number of 4. It has 2 neutrons and 2 protons, so 2 and 4. So this is how you write it. In some old literature you might find atomic number or mass number written on right hand side. Okay, but don't worry about it. Okay, that was the convention before, but now we write both of them on the left hand side. Alright, on the bottom we always write atomic number, on the top we always write mass number. And again, atomic number is simply number of protons and mass number is simply number of proton plus neutron. So if you want to calculate, say, number of neutrons in an atom, so number of neutrons present in an atom is simply equal to its mass number minus its atomic number. Alright, and as you know, what is the significance of atomic number and mass number? So atomic number, you know that for a neutral atom, number of proton is equal to number of electrons. So atomic number is also equal to number of electrons, and the number of electrons and their arrangement around the nucleus is what determines the position of an atom, alright, in the periodic table, and also the kind of chemical reactions that it is going to take part in. Alright, so atomic number is quite a significant number. Alright, and that is why we have to study it. Whereas mass number determines the atomic mass of any atom. Since we ignore the mass of electrons and we assign mass of 1 unit to both proton and neutron, so total mass of, let's say if you want to calculate atomic mass of helium, so it has total number of 4 nucleons. Okay, 2 neutrons and 2 protons, and each of that nucleon is 1 unit in mass. So total atomic mass of helium is 4U. Alright, in atomic mass scale it is 4U. Similarly, let's say if you have sodium, so total mass or atomic mass of sodium in our calculations is 23U. Alright, so in mass number we have only protons and neutrons, in atomic number we have only protons. Alright, so if you want to calculate mass, atomic mass of sodium in grams, we know that it is 23 gram if I have 1 mole of sodium atoms. That is, gram atomic mass of sodium is 23 grams. Okay, if I have only one single individual atom of sodium, its mass is 23U, as we have studied in mole concept chapter. Okay, so both these numbers are quite significant and you have to remember their definitions, their notations, and how we represent them while writing notation for any element. Alright, so until next time, and once again, thanks for watching Edupedia World videos.